The new product introduction process spans both the design and manufacturing of printed circuit boards and requires clear and complete communications between the two. Mentor's Valor NPI application software helps you accelerate your new product introductions. To improve any process, you always look to shift actions and decisions to the left as much as possible. With PCB design for manufacturing, best practices are to perform DFM concurrent with the PCB layout process. That is why we have developed a Valor NPI DFM analysis add-in for Expedition. This allows the designer to get access to DFM analysis in an environment they are accustomed to using. There is no training required or different software tools to learn. The setup of the DFM rules are easily managed from the Valor NPI application. Within Valor NPI, you simply open the Analysis Definition Manager, also known as the ADM, where you can define your intelligent constraints values based on the manufacturing processes to be applied and the PCB design attributes. These are what we call factors. From within the ADM, we can create and manage different classification sets based on technologies or suppliers, which allows you to further tune your DFM constraints to best meet your needs. From this Factors tab, we utilize factors and attributes of a design to classify it appropriately to drive the desired constraints. A design can contain thousands of various factors, and from this window we can easily manage the factors of interest for this classification set. For the Classification tab, we can utilize factors to properly classify the design. Once you've added your desired factors, you can easily test your design for verification. The system works left to right, and as you can see from this test, both advanced and complex pass, so the design will be assigned as an advanced classification, where this will carry over to the constraints area to aid in the proper constraint value settings. From this Constraint tab, we categorize our constraints within analysis type, such as etch, mechanical, solder, quality, process setup, and component placement. This aids in both the creation and management of the constraints, as well as assists in the review process to pinpoint the types of issues you wish to review. We'll start by taking a look at the etch category first. In this example, you can see we set up the constraints to utilize the classification assignments from the Classification tab, as well as additional factors such as copper weight and layer position. This allows us to be very precise about how we want to apply different constraint values based on these design characteristics. We also present a graphical representation to describe what is being checked and why it's important within the manufacturing process. It's important to note the different constraint values that have been set for 1/2 ounce versus 1 ounce on both the inner and outer layers. As we run this classification set on our Expedition design, these rules will automatically be applied to the correct layers based on the Expedition board stackup. Of course, these rules would typically be set up by your PCB technical lead, manufacturing expert, or possibly from your new products introduction team. As a PCB designer, you simply select the desired classification set within Expedition and review the results. So let's jump over to Mentor Expedition and see how easy it is to apply these rules against your design. Before we run the analysis, let's take a quick look at the board stackup, as it plays an important role in passing intelligent information such as material thickness, copper weights, prepreg versus core information to your Valor NPI analysis engine. As you can see, the stackup includes material and metal thicknesses along with technology types such as prepreg and core, so there's nothing to do here but to let the system use this information to set up the desired constraint values. Now let's select the Valor Dfm Gui, and the first step is to start the Valor DFM to get the access to the classification sets. Once that's completed, we now have access to all the company supplied classification sets along with the ability to select the desired severity filter. In this example, I only have one classification set. We'll go ahead and select that, and we'll go ahead and select the red severity filter. Once we've made our selections, simply select Run Analysis. Once the analysis has completed, you will see a ready indicator at the bottom of the Valor DFM Gui. Now that the analysis is completed, we're ready to review the results through the Hazard Explorer, just as you would any other Expedition constraint results. Make sure that you've selected your Valor DFM tab within the Hazard Explorer window, and you're ready to review results in a way you're accustomed to doing. The first results that we want to take a look at are the CAD shorts. From this window, you can see the severity setting, measured value, limit value, which is basically the constraint value we set within the classification set, the violation layer, and both the elements and the nets involved with the issue, and of course the standard columns associated with issue acceptance. Once we select an issue, the system automatically changes to the proper layer and zooms into the issue we selected. And from here, we can easily make the correction and move on to the next issue. Let's now jump down to the via annular ring. As you can see, we're looking for an annular ring of 3.4 mils, while we have 8 vias that are measuring only 2. We can select the properties of the via for verification, and of course, if we wanted, we could fix this directly from within Expedition, but maybe we want to accept these issues, so we'll select all 8 issues and apply Accept Selected Hazards. This marks these issues such that they can be hidden in subsequent DFM analysis for this design. Looks like we have a couple stubs in our design, and as you know, stubs can act as an antenna and may cause other DFM issues, so let's go ahead and remove these. Let's jump on down to the slivers. The severity for slivers is indicated here in red, while the measured value of this sliver is 1.28 mils. My constraint is looking for at least 3.4 mil spacing, and this problem was found on the signal layer 4. Copper sliver width is the narrowest width the resist material can be without having a negative impact on the yield. Copper slivers are the side effect of PCB manufacturing processes in which the chemical etching removes the copper from the laminated material. Having this too narrow can cause acid traps as well as shorts through the fabrication process. So we want to go ahead and quickly fix this issue. Let's fix one more issue by taking a look at exposed via to exposed via violation. Here I have only 1.9 mils while I'm looking for 3.825. And just to tie this back to our constraint settings, you can see this design was classified as advanced. And when we look at the settings within the ADM, you can see for the outer layer of 1 ounce, we're looking for 3.825. Fortunately, we have room here, so we can go ahead and fix this and move on. And lastly, here we'll just take a quick look at wide trace narrow pad. This check reports occurrences of wide trace entering into a narrow pad. Such connections can cause solder imbalance, leading to solder starvation, resulting in insufficient solder fillets. We could fix this, but for this demo, we'll just accept it and move on. I also want to point out that the analysis detected that this design was a microvia HDI design, so it ran both the microvia checks as well as the HDI checks. If I were to hover over a couple of these checks, you can see the analysis understands the differences between laser versus drilled vias, and of course, you can use this factor as a means to set different constraint values based on drill types. Now that I've made a few updates to this design and accepted a few issues, let's rerun the analysis and review the results. You'll see the issues we fixed no longer show up on the list. The items we previously marked as accepted are maintained, while other results are still available for review. That wraps up our Valor NPI add-in for Expedition. Valor NPI add-in is the best way for a PCB designer to review troublesome manufacturing-related defects such as copper and solder mask slivers, exposed copper, line width and spacings based on layer copper weights and layer positions, all within the tool you are accustomed to using, Expedition.